Hello everyone, this is a quick information video about the term project. So first of all, the term project has its due. You have plenty of time, but the announcement is also important. Therefore, this video is here. Now, first of all, you have to form a team of 5 people because you will be uh, carrying this out as a team. So this is a team assignment. Um, but even though this is a team assignment, even though you have still some time, this is a term project, so therefore you will be asked to prepare a report about your project. Now, of course, there will also be a presentation, so you should probably also create a PowerPoint slide or maybe a LaTeX. If you use LaTeX, you can also prepare a slide there. So, what is this term project about? Well, you will have a sample project.pdf file, which is basically just there for you to understand what type of topic you should choose or what you are expected in terms of this project. Since it's called a project, it is really a project. It has its duties, and it's not just something that is a 5-page long thing. It is a project. So before I dive into details, let me show you what you might end up doing in. Um, First, you have this nice report where your report defines actually your control problem. You can read it in details and it has some references. So it's kind of an academic paper in that sense, or like a dissertation or a thesis if you want. But of course, you're just expected to focus on reporting stuff, finding stuff, researching stuff, and at least having some MATLAB and control involved in it. So because this is programming techniques in control, we want you to use some programming, some control system knowledge, and a project, and you to report it. So here we have a lung system here. There's a pump, there's an oxygenator, and there's the human body. We have carbon dioxide and oxygen, of course, O2 gas and air. And yeah, this is kind of a control problem. If the human body has a lung dysfunction, you need assistance by a control system that kind of regulates your oxygen, carbon dioxide in your blood. So, of course, this is just vaguely putting it. There are many details to it. If you look at the definition here, there's some disease definition here. And yeah, yeah. Um, Here we can see there's a carbon dioxide rich blood. It kind of tells you what the problem is. And in this project, you're expected to create a simulation environment for an ECMO device in Simulink MATLAB, including the human model, and design a closed-loop control system to help critically ill patients suffering from COVID-19 infection. So yeah, it is nice to have a introduction part. You can read it in detail. I'm not going to read it because it will take too long, and you can read it yourself. So why? Um, but it is important that you give the quick outline of the topic or maybe some critical definition, and then with one paragraph you just say what you are going to do. You have the option of choosing your control problem, so you're not you don't have to use this exact system and these tasks, but you are going to search a topic for yourself. So yeah, here we have the quick definition, quick introduction, and what it is going to do. Well, there's this modeling part. We have the human body. We will have these parts here based on research. And we will also have a little control here. So it will kind of try to stabilize or kind of try to assist the human body that is suffering from COVID-19. So, now the preliminaries, well, we have, first of all, there are some functions that are going to implement it here. This is kind of the MATLAB part, as you can see here. The pole zero gain is to calculate the pole zeros and gain given a transfer function. Uh, And then there's also this amplitudes. It will use Simulink to find the amplitude of a periodic signal. This will change, of course, in your case. You will implement some functions, and those functions will be in your report, and that would be the preliminaries. Now, you can think about this as like some functions that are necessary and not available in MATLAB. Then we have the system model, the mechanics model. This is a representation. You can just look in the detail, but it is kind of an RLC circuit. So we are able to model it like this. Therefore, we have this model. Everything is based on basically research and the papers available in the literature. There are references, you can check them out. You can see that there's some control related transfer functions in here. So if we have a linear model, or if we can represent, for example, the tube, the lung, with some resistors, and the capacity of the lung with a capacitor, and then there's this flow, we can represent this as an electric circuit. Therefore, it has a linear model to it. So therefore, we have a linear model. You can see there are some sensors, maybe some filters. They're also added in here. And then you have this control system. You can see that it is called the closed loop control system for the volume control, the volume of air that is going to be pumped, for example, into the lung, or maybe the air in the lung. So therefore, you have the uh, model of a real world application, or even the human body. So it is important to note this because you will probably have that in your system too. Then we have the controller, which is an integrated controller, and then you have some other aspects of your model. For example, there's dead space in the model. We add this part too, so that the model becomes more realistic. Yeah, it is still there. There we go. We have this. There are. You can see that this is a complex model, by the way. It is not just a simple model with a single transfer function. There are several transfer functions, several conversions, several assumptions, etc. So we have a highly nonlinear model. So the aim here is to use Simulink and the complex system and try to represent that as accurately as possible. So it is kind of a real world application, and it tends towards the actual model, but our control model will not be that complicated. It will be maybe a linear transfer function if possible. We will design a controller and then plug that controller, or the whole control structure, into the realistic model and see what's really going on, if it's working, how good it is working. Now, of course, this is not a control system design course. Therefore, you can just use any optimization tool in MATLAB that is available to you to come up with controller with parameters that should be tuned. You can just tune everything as you wish using MATLAB's full support. You can use the genetic algorithm, you can use fmincon, you can use even the PID tuner. You're free to come up with a controller, but the thing is, you should know how you have designed it and why you have designed it like that. Trial and error is accepted, everything is accepted, because this is not a design course. We want you to just have a control in your system, have a complex system, and plug them together and see them working here. We have some extra stuff going on here, which is system specific. Now we have a second part here. There's another model here, the pump model, because it's a complex one, the oxygenator model. That's also here. And you can see most of the time the real world applications are just differential equations. You can see there are differential equations. And yeah, we can do some nonlinear stuff here. There are some assumptions again. And yeah, there is a subsystem created. You can just read this and inspect it in more detail. But this is just a long system example. Keep that in mind. So you can choose any control system or any system that can be controlled. But the limitation here is to come up with a complex system. So for the term, you can see here, for example, we have the PID type controller. We're just going to connect them, etc., etc. Now this is from the previous years, of course, and where we were giving you the system, but this semester we decided to leave the decision to you because maybe you're not really into biomedical systems. I myself am not really that knowledgeable in this area, and I might prefer maybe control systems on vehicles, on the automotive industry. Maybe you can research your or find a system that suits you the most. If you have more fun with your system, because it's going to be a complex system, then it would be more fruitful for you. Therefore, we left the decision to you. You can just look at this example and find a different example for you or different project topic, and then decide upon that if you want to research that. Of course, before you decide on that, you should research a lot. And during your research, you should just write down some or save some articles or papers or maybe dissertations or thesis because you will reference them. And when you go to your lecturer and ask if this is a suitable project for your term project, you should be able to discuss it. Don't come up with an idea that's not on paper, that's not relying on any scientific paper, because then it's not an idea at all. You should have a clear picture, a plan of your project. I'm going to implement this model in Simulink, and it seems like in the literature they are designing these types of controllers. There's even a design example. I'm going to implement my controller to it or my design to it, and I'm going to run this, and the system is complex enough. If you say this and come up with some papers, then you should be good to go. So step one, form a team of 5 people. Step two, decide on a certain topic that can be complex like this. And step three, find the papers that mostly interests you and have good examples and complex models in them. And then the next step would be then to seek for the lecturer's validation if it's a valid project. Once you get the validation, once you validated that this is the topic that you can work with, then you can start on working on your project. Now here are some steps. This was step one. Then you are going to prepare a detailed report, which is most probably going to be some references, some introduction part, and the process of creating the complex Simulink model, and then maybe some trial and error or optimization or toolbox generated controllers, and then the connection of the complex system to the controller, and then seeing some meaningful simulation results, and then conclusion. That would be probably the structure. You can check out the sample project.pdf file. You have to propose your suitable topic to your lecturer or to me, your course assistant. After that, you will study the chosen topic. So you have to first decide on the topic. And here are the basics. You can again read them. A complex physical system, process control systems, flight control systems, power energy systems, autonomous vehicles, biological systems, etc. There are many of them. You just have to decide on one of them, and you are going to work with that. And give a brief information about the system. This brief information ideally would be consisting of some papers that you have looked through and decided upon, and so that you have a clear plan. This controller, this physical system, these are the details of the model. I'm going to plug this and run it. So basically that should be it. Once you have once we have decided on the system, once you have validated that, determine the inputs and outputs, give some performance specifications. For example, if it's an autonomous vehicle, you will have the most complex model that is possible of a car, for example, but then you're going to design the speed and position controller of the vehicle. Um, your limitations would be then the could be something like minimum energy consumption, but then maximum battery life. Then you need the battery model to model the battery, but it should be the best model that you can find in the papers, because otherwise just putting in a capacitor and a resistor does not represent the battery. So it should be a complex system there. Once you have set those goals, you are looking for controllers, maybe PID controllers, maybe PI controllers. You can then try the genetic algorithm to run several simulations to optimize the speed and position controller of your vehicle. And then, well, you should just show the model, plug the controller, show the results, and then conclusion. Um, yeah, obtain a very detailed mathematical model, because you're going to design a controller to that. Find some references, journals, conference papers, etc. Obtain transfer functions if possible. If it's a highly nonlinear system that is not possible to um, linearize, I would maybe say that you should not use those systems, because it could be too complicated for you. But if you still insist on that, you can also still use that. Have some root locus Nyquist Bode stability analysis of the system, so that we have some related stuff about control. Don't pick something that we don't even know about, or it's highly specific to a certain area. You should still have some classical control in it. Implement your model in Simulink using Simscape as much as possible, because Simscape has some nice features. Even though we didn't address that, you can just research and do that, so it's not that off, I would say. And then have a function block at least somewhere you would need it. Probably you use a closed loop control scheme, any controller that you want that is suitable for us. Analyze the closed loop system together, maybe add some system parameter changes, so that you can see that what happens if we have some variations. For example, in the car example, in the autonomous vehicle example, let's say we have a certain weight. What happens if we change the weight a little bit? How does the energy consumption and battery life get affected from that, etc., etc. So you can build up the scenario. It depends upon the system. And analyze the closed loop system transient response. Maybe you have a speed profile to follow. Does it follow? If it follows, how good does it follow? What about noise, etc. So yeah, this is it about the term project. You first need to form a team of 5, and you need to just decide on the topic and get a validation for your topic. Don't just pick a topic and try to and come up in the end of the semester and say, I decided upon this. Seek validation, ask your lecturer if it's okay to study this one. Otherwise, don't start, actually. Get a validation. So that's basically it. I am going to explain stuff in Turkish too for the non-native speakers. So yeah. Dönem projesi arkadaşlar. Dönem projesi için Türkçe açıklamada yapayım. Öncelikle 5 kişilik takımlar halinde yapacaksınız. O yüzden önce takımınızı oluşturun. Bir sonraki adımda ise bu 5 kişinin tabii ki aynı konuyu çalışmak istiyor olması gerekir. Ve konuyu da siz belirleyeceksiniz. Fakat konuyu belirlemek derken bu 5 kişi oluşturduktan sonra literatür araştırmaları yapıp ilgi alanlarınızın özellikle yönünde literatür araştırması yapmanız gerekir. Elimizde karmaşık bir sistemin olması gerekiyor. Gerçek hayata olabildiğince uygun karmaşıklıktaki bir sistemi ele alacaksınız. Bu sistemin matematiksel modelini Simulink Simscape ve Simulink sonuna kadar kullanarak ayağa kaldıracaksınız. Ayağa kaldırdığınız bu sisteme kontrol uygulayacaksınız. Fakat kontrolörü tasarlarken veya elde ederken bu sistemin basit bir versiyonunu kullanabilirsiniz. Ama biz e, dönem projesinde aslında olabildiğine gerçekçi modelin üzerine basit bir kontrolör kullanarak çalıştırdığınızı görmek istiyoruz. Temin aslında İngilizce anlatırken de gösterdiğim bu PDF dosyasına da bakarsanız insan vücudunun modeli, oradaki pompanın modeli vesairenin modeli olmak üzere burada modelin ne kadar da karmaşık olabildiğini gösteriyor. Bu tarz bir karmaşıklıkta olmasını baz almanız gerekiyor. O yüzden de bu örnek PDF'e bakabilirsiniz. Burada işte çok da bilinmeyen şeyler olmamakla birlikte birden fazla bir şeyin bir araya getirilmesiyle oluştuğu için biraz karmaşıklık içeriyor. Ama olabildiğine gerçekçi bir modeli ele alıyoruz. Tasarladığımız kontrolörü tasarlarken veya elde ederken daha basit bir modele geçiş yapabiliriz. O konuda sıkıntınız olmasın. Ama Simulink ayağa kaldıracağınız sistem olabildiğine gerçekçi olması gerekiyor. Bunu da göz önünde bulundurarak aslında bir takım makaleleri hedef seçmeniz gerekir. Yani hocam ben şunu buldum, buradakini yapabilir miyim diye sormanız gerekir. Sadece bir fikirle gelmeniz bana sorarsanız tam yeterli olmayacaktır dönem projesi için. Fikre dair bir takım PDF'ler vesaireler elinizde olursa şöyle bir hızlı bakıldığında karar vermek daha kolay olacaktır. Nasıl yapacağınızı planlamış olarak gelip hocam bu proje konusu uygun mudur diye onay almanız gerekiyor. Onay almadan tabii ki başlamayın. 5 kişilik takımınızı oluşturun. Gidin konunuzu araştırın. En kısa sürede makaleleriyle ve planıyla belli bir şekilde e, özellikle Emre hocanıza sormanızı daha çok tavsiye ederim tabii bu konuda. Ama bana da gelebilirsiniz. Benim yetmediğim tarafta Emre Hoca'ya bakabilirsiniz. Bu konuya karar vermiş olmanız gerekiyor. Dönemin sonunda bir rapor teslim etmiş olacak. Bir de sunum dosyası hazırlayıp sunum yapmış olacaksınız. Dolayısıyla bunu da göz önünde bulundurun. Konunuza hakimiyetiniz vesaireniz sunum esnasında belli olacaktır zaten. Hazırladığınız raporun profesyonel olması da gerekiyor. Profesyonelden kastım tabii ki buradakini yine örnek alabilirsiniz. Başlıklar halinde denklemlerin verildiği, kısaca bir şeylerin anlatıldığı, referansların verildiği, sonuçların güzelce anlatıldığı bir rapor. Rapor zaten siz yaparken bir şeyler birbirine karışmasın diye bile not aldıklarınızdan oluşabilir. Dolayısıyla dediğim gibi onay almadan projeye çalışmaya başlamayın. Ve sistemin karmaşıklığı az önce de örnek verdim. Mesela örneğin otomotiv endüstrisiyle ilgileniyorsunuz diyelim. İşte bir elektrikli araç modeli. Olabildiğince gerçekçi, olabildiğince karmaşık bir modelini bulup Simulink ayağa kaldırmayı hedefleyip atıyorum bunun işte hız kontrolörünü ve konum kontrolörünü biz yapacağız dediğinizde onları da olabildiğince basitleştirip işte genetik algoritmadır, optimizasyon toolbox'larıdır, PID tuner'lardır vesairedir. Her nerede tasarlayacaksanız orada tasarlayıp gelip bu kompleks sisteme takıp orada çalıştıracaksınız. Burada tabii ki bazen amaç otonom araçlarda örneğin işte e, şarj menzilini artırmaktır. Yani işte bir şarjla daha fazla menzil gitmektir. Ya da tüketimi azaltmaktır. Veya işte hızlanmasını şöyle iyileştirmektir vesaire gibi o fiziksel karmaşık sistemin bir özelliğini de kontrol etmeyi hedeflemeniz gerekiyor. Dolayısıyla burada işte matematiksel kısmın, fiziksel sistemin karmaşıklığı oldukça önemli. Matematiksel modelin detaylı olması önemli. Ama daha sonra kontrol uygularken tabii ki biz basitleştirip bir şeyleri üzerine kapalı çevrim yaparız. Bu bir tasarım dersi veya tasarım projesi olmadığı için tasarım kısmını toolbox'larla, optimizasyonlarla veya deneme yanılmayla bulmayı hedefleyebilirsiniz. Bu bir kontrol sistem tasarımı vesaire olsaydı o zaman bunlar da beklenirdi. Ama siz kontrolör tasarlama konusunda henüz başlangıç seviyesinde olduğunuz için burada da parantez içinde yazıyor bakın. Optimizasyon tabanlı kontrolörler, kontrolör tasarımları, algoritmalar, kural tabanlar ne isterseniz onları kullanabilirsiniz. Önemli olan kontrolün, klasik kontrolün bir kısmının kullanıldığı, kök eğrisidir, işte Bode'dir, Nyquist'tir, e, kararlılık tanımındaki gereken bazı şeylerdir. Bunlardan faydalandığınız, gerçekten karmaşık olan ve gerçekçi sisteme yakın olan Simulink, Simscape yardımıyla modellediğiniz ama kontrolü de temel anlamda e, elde ettiğiniz kontrol kapalı çevriminde gördüğümüz bir sistemin olması gerekiyor. Bu sistemde bir takım şeylerde değişiklik yapılabilir. Tekrar otonom araç sistemine geri dönersek, örneğin üstündeki ağırlık değişecektir çünkü kaç kişinin aynı anda bindiğini bilmiyoruz. Bunun mesela şarj süresine etkisi ne oluyor veya kapalı çevrimi aldığımızda, aracı çalıştırdığımızda farklı kütlelerdeki davranışları benzer midir? Ya da işte teker yarıçapı değişti, bilmiyorum, başka bir yerde başka bir şey oldu. O yüzden de işte şöyle davranıyor gibi bir takım basit parametre değişimlerine karşılığı nasıl davrandığını göstermenizi bekliyoruz. Bu mesela araç örneğinde bir rüzgar modeli bulup karşıdan rüzgar estirip aracın rüzgara karşı yakıt tüketiminin nasıl değiştiğini veya ölçüm hatalarının başka şeyleri nasıl etkilediğini falan gösterebilirsiniz. Dediğim gibi burada 5 kişi olduğunuz için, MATLAB'i sonuna kadar kullanabileceğiniz için, Simscape'i en ileri seviyeye kullanabileceğiniz için, ilgi alanınız yönünde böyle bir çalışmayı 5 kişi yapmanız veya ilgi alanları benzer 5 kişi olarak bir araya gelmenizi tavsiye ediyorum. Onun haricinde dediğim gibi önce onayınızı alın. Onay almak için geleceğinizde hocanıza veya bana elinizde bir takım tutulur, elle tutulur makale veya referanslar olsun ki onları yapacağız deyin. Bir de adım adım nasıl modelleyeceğinizde de 3 aşağı 5 yukarı bir fikriniz olsun ki dönemin sonuna kadar zamanınız olsa da bu ister istemez belli bir süre alacaktır. Şimdiden başarılar, görüşmek üzere diyorum.